back over. And he got distracted, found a target while he was walking, so he's going to take care of those targets before he returns home. And as you can see, zombie gets too close to him, he backs away and continually shoots at the zombies. Alright, and it charges, and it updates the charge particles with the current color of the turret tip, so that's good. Hello everybody, Yellow Mustang here again with another Roblox scripting tutorial. Today we're going to be making a advanced mobile turret AI with custom animations, pathfinding, raycasting, all that good stuff. So I have prepared a turret model here. And inside of him, I got a basic animation script that I've made. It's pretty simple. Just whenever he's running, it'll play the running sound, run the running animation. When he's jumping, same thing. Jumping animation, jumping sound. Pretty simple stuff. And then this wait loop basically just keeps the animation looping through as he's walking until he stops walking. So that's all pretty basic. Normal humanoid in him. We have a team value, and the value is set to red. Let's switch that to green, because he's green now. So this is going to be what team the turret is on, where you can insert this into any humanoid to allow the turret to be on its team. So I will show you guys how that works when we actually start writing the script. Legs and stuff, that's just his legs. Humanoid root part, I just have hidden inside of him. Neck, all that good stuff, yada yada. Where's the head? In the head, I got all the turret sounds already, so we're going to have him like charge up. I got a jump sound, shoot sound, all of that. Everything's welded, and I got the motor 60s in the humanoid root part and the torso. And then I've already made some custom animations to go along with this guy that I got working before the video, so that's all good. So if we go ahead and run this right now, you'll see all he does is just stand here. We're going to have him chase down these figures, shoot some lasers, and wreck some kids, and light them on fire when he kills them also. So it's going to be pretty good. Let's go ahead and create our script as usual. Name that script AI, as we do on the Yellow Mustang channel, if we could spell it correctly. There we go. Okay, and now we start off with the process of declaring a million local variables. So local myHuman equals script.parent. Wait for child a humanoid. Local myRoot equals script.parent. Wait for child a humanoid root part. Okay, simple enough. Local myHead equals script.parent. Wait for child head. Local head weld equals myHead. Wait for child. Wait for child. Believe it is head weld. Yep, there we go. And then local tip equals script.parent. Wait for child tip. Then local flash equals tip. Wait for child flash. Okay, so that's just a light value I have inside of the tip of the laser. So each time he shoots, we will enable that, and then we'll get a little flash of light. Be a nice little touch. And then local myTeam equals script.parent. Wait for child team. Okay, should be good. And then we will declare our sound variables. So do local shoot sound equals script.parent. Wait for child shoot. No, no, it's in the head, isn't it? Okay, so not script.parent. myHead. Wait for child shoot. Okay, good. And then local charge sound equals myHead. Wait for child charge. Okay, should be good. And then we'll set up our respawning variable. So local clone equals script.parent clone. So that will keep track of our original character, so we can make a copy if it dies or loses health or something like that. Okay, so now we're gonna do some a boolean here. So local gun cool will be our gun cooldown tracker when in between shots. Local max charges equals 10. So that's gonna be our maximum clip size. So we'll shoot like 10 laser shots, and then we're gonna essentially recharge, so we're not just constantly shooting. Then local charges equals max charges. So that's currently how many charges we have to use. We'll just set it at 10 by default, so just the max. And then local home equals my root dot position. So if he has no targets, then he's going to return wherever in the workspace that he was standing originally. So it'll be essentially like a guard. It'll go back to base. So that'll be good. Let's start this off with the get unstuck function. So get unstuck, my human, move, vector.3, new, map.random, -1, 1, 0, map.random, -1, 1. Okay, should be good. Then we'll do my human dot jump equals true, and then weight 0.5. So whenever our humanoid gets stuck in our pathfinding or something, we'll call this get unstuck function. This line here tells us to walk in a random direction in a straight line somewhere, and then we'll jump, and then we'll just keep walking in whatever direction for half a second. And normally that's enough to get the turret unstuck from wherever it happens to get stuck. Next function we'll set up is the check dist function. So check dist target, and this is just going to return how far something is away from us. So we'll do my root dot position minus target dot position dot magnitude. So this will just return the distance based off of our root part, how far away something is, so we don't have to type this line of code every single time. This shortens it a little bit for us because we're going to be checking the distance a lot. So that'll just save us some time as we go. Let's move this up a little bit for you guys. So the next thing we're going to do is the check site. So we do function check site target, and we do local ray equals ray.new. Starting position is going to be my head dot position because that's where we're going to be shooting from, so that's where we want to check the site from. And then we're going to do target dot position minus my head dot position dot unit times 75. So 75 studs away from us is the furthest we're going to be able to see the target. And then we will do local hit position equals workspace, find part on array with ignore list, and we'll just plug in our array in there, and then we will ignore our body parts when we're drawing the array. So that will include all of our body parts just by typing script.parent, so that'll be good. Then we'll do if hit, so if we hit a part, then if that part is a descendant of target.parent, then continue, then return true. Okay, and then if we don't, then return false. So we're gonna draw a straight line from our head to whatever target we're aiming at, and then if we hit that target, one of its body parts, then we will return true. If we don't, if we hit something else or nothing at all, then we will return false. So that's a simple way of doing array casting there. Good setup for that. Next function we'll set up is the find target function to actually find us some targets in the workspace. So do local dist equals 100 in this case, then local target is nil. That's just a placeholder for when we find a torso. So do for IV in pairs, workspace, get children, do, and then we'll do local human equals v, find first child, humanoid. And then we'll do local torso equals v, find first child, torso, or v, find first child, humanoid, root part. So we're going to be checking to see if there's a humanoid in whatever object in the workspace we're on, and then if it has a torso or if it has a humanoid root part, it doesn't matter. As long as it has one of these, then it will assign it to torso, and then we can go from there. Now we will do if human and if torso, then continue. So if V contains both of those, then we will continue. And then we will do one more thing up here at the top. I forgot. We need to check for the team. So do local team equals V, find first child, team. And then if it contains a team, then we're going to check if it is our team. So we're going to do if team.value is not equal to our team, so my team.value, then continue. Then we are going to run some additional checks in here. Actually, let's move this around. We are going to do if we're going to check the distance first. So we'll do check dist. Oh, this is spelled wrong up here. Change that. Check dist, not chest. So do check dist. Target is less than distance, and human.health is greater than 0. Then continue. Then we will check the team. Okay. Okay, that should be good. It's a little bit different than how I have it, but I think that'll be more simple. So if check distance is less than our dist and human.health is greater than 0, then we will check the team. And then if there is no team, then we're going to set the dist to be check dist target, and the target is going to be torso. Or if we find a team and the team is not our team, then we will just update the distance and we will set the target is equal to torso. Okay, so that's all fine and dandy there. Then return target. And the target essentially is going to be the torso of whatever humanoid we find in the workspace that is either has no team or is not on our team. Okay, so continuing on here, let's go ahead and set up the pathfinding. So we will do function path to target, and do local path equals game get service, pathfinding service, create path. We'll just use default parameters because, I mean, the turret is basically the same size as a normal humanoid. And then we'll do compute async. Starting position will be my root dot position. Ending position will be target dot position. All right, so that should be good. And then we'll check the status. So do if path dot status is equal to enum dot path status dot success. Then continue. Else we would do, this is a path fail, so just take note of that. So now we'll do local waypoints equals path get waypoints. So that's going to give us all the waypoints, and this is essentially a table now that we need to loop through. So we will do that with a for loop. So for IB in pairs, waypoints do. We will do check the action. So if v.action is equal to enum.path waypoint action.jump, then we will have our human jump equals true. And continuing on here, we're going to have him aim at the target in here. So we'll just comment that out for now. We haven't set up the aim function yet. Now we will have the human move to v.position. So that is going to be the current waypoint that we're on. V will be. And then we're going to spawn a function in here to check to see if we need to jump. Again, like a double check essentially. So we're going to do wait 0.5, so half a second there. And then if my human dot walk to point dot y is greater than my root dot position dot y, then my human dot jump equals true. So that's just going to double check that our root position is on level with whatever we're trying to walk to. So if it's not, if it's lower, then we're gonna just jump, and that should correct the issue there. Now we'll do local move success is equal to my human dot move to finished wait. Okay, so this is going to pause the script until the move to event fires. So until we get to our waypoint. If we don't get to our waypoint, this will time out in like 7 seconds, I believe. And if it times out, then it will return false. If we get there successfully, then it will return true. So we want to check. So we want to do if move success, if not move success, in case if this is false. If we don't make it to the waypoint, then we want to get unstuck, and we want to break out of this path because it's no longer valid. So we want to generate a new path because we didn't make it to the waypoint. We're off path. It's not going to work anymore. So we'll just go ahead and break out of this and get unstuck. So move to a different position and then just reset basically and try to generate a new path. So that'll be all good there. Next, we're going to see if the target that we're moving to has moved. So do target dot position minus waypoints, number of waypoints. So the last waypoint dot position dot magnitude is greater than 15, then break. So if our target moves away from our ending waypoint, then we will break out of this and just generate a new path, because if we're walking to the old spot, then we're just wasting time. We want to walk to where the target currently is, not where the target was originally. So that'll keep it so we are within 15 studs of the target at least. So get us pretty close. Now we will do we'll check if we're too close. So do if check dist target is less than 15 and check site target, then continue. So if we are within 15 studs of the target and we can see the target, then we are going to stop pathfinding. We are just going to stop in place because we're close enough. We're going to be shooting the target if we can see it and we're that close. So we will just stop right there and then just stand there and shoot the target essentially. Okay, so now we will do if I is divisible by 5 equals 0. So every fifth waypoint, we're going to perform this next check. We'll do if find target is not equal to target, then break. So this is going to search the workspace for the closest target near us, and if that closest target is not our current target, then we'll just switch to the closer target essentially, and we'll generate a new path to that. So this will go ahead and break us out of this path, and we can then generate a new path. Okay, continuing on here, we will do if check site target, then continue, and we will do tip brick color is equal to brick color dot new really red, and we will do aim at the target and we will shoot the target once we get those functions set up. If we cannot see the target but we're walking towards the target, then we will set the tip brick color to brick color dot new neon orange. Okay, that should be good there. Okay, yeah, neon orange. So this will kind of give us like a status of what the turret is thinking by changing the tip brick color. It'll be a little more dynamic. It'll look pretty good. So if the path fails, then we will just run the get unstuck function there. So that function should be. Let's go ahead and set up the main function, and we'll set up our main while loop as well. So while wait do, and we will do if my human dot health is greater than 0, then continue. And then we will call main. If we are less than 0 health, then we will break out of this because we are dead. And we don't want to be running any code if we're dead, because that's just a waste of resources. So now in main, we will do local target equals find target. So if we have a target, then continue. If we don't, then no target. On no target, we're going to have the turret walk home, but we'll set that up in a minute. So we will check, we'll do if check dist target is greater than 15, then path to target. So if the target is further than 15 studs away from us, then we'll use our pathfinding function we set up above to pathfind our way over to the target. We'll do else if in here, else if check dist target is less than 5, then we will back away from the target somehow, back away, and then we'll do else if check dist target is oops, get rid of that. If check dist target is less than 15 and not check site target, then we will path to the target. So this checks if we are further away from 15 studs, but if we are closer than 15 studs and we still can't see the target, then we're going to path find to the target anyways, because it could just be on the other side of a wall from us or something like that. So this will keep us from just standing there not doing anything. There was issues with that, so I added that. Next thing we're going to do here is set up some more logic. So we'll do if check site target, then continue. If we can see the target, then we're going to do tip brick color equals brick color dot new really red, and we are going to aim at the target and we are going to shoot the target. We're just commenting these out for now because we have yet to set up those functions. We will set them up in a minute. Yeah, so that should be good there. We'll set up else tip.brickcolor equals brickcolor.new neon orange. Okay, and that should be good there. So excuse me there. So if we have no target, we will do if my root position minus home dot magnitude is greater than 20, then tip dot brick color equals brick color dot new cyan. So we're going to, so if we are further than 20 studs away from our home base, basically where we spawn in the world, then we are going to set our status to cyan, and then we are going to go back home. So we're too far away from home and we have no targets, then we are just going to walk back to home and set our tip of the turret to cyan. If we're close enough to home, then we will set the brick color to brickcolor.new really blue, and then we will just idle in place essentially. I'm gonna have the turret like rotate around and just scan for targets essentially. And then let's see, down here we will do weight 0.5. If we don't have a target, then I don't want to just spam the find target function. It uses a lot of resources. We'll give it like a half-second delay in between that if we have no target. And then at the end, we will just set target is equal to nil, so we can find a fresh target every single time. So that should be good. Let's go ahead and do a status check and see if this guy is moving or if we have any typos or anything. So right off the bat, line 28, cannot find target. So I probably called check dist without doing something. Okay, so in here, in the find target function, it shouldn't be target, it should be torso, because target is nil, so it's a nil value. So just check dist, switch all these to torso. Okay, so that should clean that up. Let's clear the output and try this again. Okay, see the turret's now moving. He's making the walking noise and he's fully animated, and he stops when he's within 15 studs of the person. And you can see the the turret tip is changing colors based on if he can see the figure or not. So when he goes behind the tree, it turns orange. If he's got a direct line of sight, it turns red. And then let's go ahead and put him way over here and see if the idle blue kicks in. So you can see turns to blue. Let's move him away from his home. Okay, turns to cyan. And then, oh yeah, we don't have the go home function set up yet, so he has the status of he wants to go home, so he would be calling that function if it was set up. It looks like he's found a target now, so now he's after the next target. he stands there, gets all good in place. So it looks like all of that code we just wrote is working fairly well.
Oh fuck, I can't believe you've done this. Oh fuck, I can't believe you've done this. Oh fuck, I can't